So hi everybody and welcome back to the C++ tutorial series for absolute beginners. This video 318, and in this video continue with our exercise. So here we stopped at number 12, and like all time you should read the question, answer the question as good as you can while you pause the video, then start the video again and compare it with my answer. And of course I will not pause the video here. And let's get started. So here it says static cast, and we're casting from a x to a int reference. So explain this code and make a code example, and like all time make a code example so that you to practice again coding and in context, of course. All right, with that said, I don't pause it, you should pause it, and I jump to the answer. So here, first of all, explain this code. Explanation. We start with static cast. So in general, we know C++ got this cast, but there are different kind of cast. There is dynamic cast, const cast, and all this kind of other cast. And important note here is a cast. What does a cast do? It tries to cast one type to another type. Here is an example. We have here a type int, and let's say I want to cast it to something a reference. Here you can see here the type is int reference. Then I can use, for example, this static cast, and then I cast it from x, my x was this int here, to this int reference, and then I bind it, for example, with a variable here. And important, in C++ you will see one more kind of cast. It is the C style cast. And how does the C style cast look? For example, here I have a C style cast. You can see it says nothing with cast because the C++ cast has all time this word cast in it anyhow. And the C style cast has just this round brackets and then the type in which you want cast in front of the variable here. And what is the big difference about the C style cast and the C++ cast? The big difference is the C++ cast is a little bit more safe and readable. What I mean with that is, if you remember, in C++ we have these different types of cast, so we can specify exactly which cast we want perform, and C++ will only perform this cast. On the other hand, for example, the C style cast, it has just one representation. What I mean with that is just you have to use this round brackets here, and then the compiler will go behind the scene through a order of cast options. Like in C++, it will check static cast, it will check dynamic cast, const cast, and the first one which fits in this C style cast will take it and make it. So when it says, oh, I found a double, and I will perform this cast which I found behind the scene. So, and that's can lead to some unsafe cast, or let's say not intentional cast what you wanted. And that's why the C++ cast is better. Like I said, there are the different cast types, and you can specify what you really want. So when you say I want a static cast and not a dynamic cast, then you write static cast. And if you want a dynamic cast, then you write a dynamic cast and not a static cast, something like that. Okay, that was that. And here you should make a code example, and like you can see, I created it with ChatGPT, this code again. And if you create a code with ChatGPT or use it from online resources, make all time what? Check the code. First of all, you can check the code in your IDE, just run it. If it works, it's the first step, but not the end step. Why not the end step? Because a code could have not syntax errors, but could have meaning errors, or what is it called? You know what I mean. It can have still errors like the outcome is strange because there are internal errors. And another way to check this is if you are not using an IDE. What we will do in future is use this compiler explorer. What is this compiler explorer actually? You put in here your code. and then on the right side you have here an output in assembly, which we will learn when we go to intermediate. You have to learn this alongside. Of course, you can start right now as a beginner as well if you are. And what I mean with learn assembly is not necessarily to write in assembly, but to read in assembly. Why will be this so important in future when we go to intermediate? Because then we can check something like this. I talked here about the C style cast, right? And this C++ cast. But actually we can check if they are doing exactly the same thing. For example, let's see, we have here this our int again, C style cast, and then I have here, okay, I have this one here, and then I have here C++ cast. But when you have here this assembly, and here is this code, let's see here. Here I have another example actually. So first of all, we start here with this int. You can see that's this one line here. And then I have here double XX. This is our C style cast. And then the same thing here, XX2 double, but with C++ style cast. And the nice thing about this compiler explorer, or let's say assembly, is you can see it highlights the blocks where, when I hover my mouse here on the right side, you can see it hovers the blocks where it is. And here in this case, we can see when I'm here on C++ cast, it's here in this block. And when I here on C++ cast here on the double, it's here on this block. And when I compare now this one, you can see they are exactly the same thing here, which means the C++ cast is right now using also the static cast version. And that's the power of later, it's let's say one power of assembly. You can exactly see if what it is doing later when you understand also this code here in assembly a little bit more. Because when you see here something different, let's say they are using here a little bit with different instructions, then you can assume they are not doing exactly the same. But this cast would be the same here. Sorry. And yeah, that's one power, and that's why we have to learn this assembly in future. Also for more internal instructions, so to see every step a little bit more in detail when we learned assembly in future. All right, but that's enough in assembly. We are not in assembly now. That was just that for check and the future talks. Right now, you should make this example, and you can see this example is very easy. We have here some casts, and again, we cast from one type. Here we have, for example, what I have here. Interesting is here. This line is also interesting. What I am doing here actually. Can you see it instantly? I hope. If not, I will say it now. At this line, I have here, this here is just an assignment, right? You can see we have here x, it's my x here. And then here's a new variable. It's called xref2. And here's my reference. So I created this reference here, and then I take the address of x. But interestingly is, what is interesting here? This x here is actually behind the scene. It performs actually a static cast int like this one here. How I can see that? And again, I talk so much about assembly. I said if I have now here the same code, and you can see here, that was that, by the way, what I showed you. Here, no, that's not the way. This is the other way, the other part. You can see this is this part here. That's this top part. And the other part here, it's the below part, and you can see they are doing exactly the same instruction. By the way, instructions are this, and then here are the registers in which they put and using. And the only thing differences here are this numbers here. This is just in which register they are, or in which line they are with an offset, but they are doing exactly the same thing. But you can see here we are using this implicit cast, which means behind the scene. We as a programmer don't see that here is a cast performed. That's why we learn it now, and we should know, here it's a cast performed, and here you make it more readable. So this and this line and this line is the same. This one is more readable. This one is that what it is performing behind the scene. And again, we can see it later when we learn assembly a little bit more in detail, which instructions are performed, how it is performed, and so on in future when we get better. But yeah, that's enough for this. And like all time, if you have any questions, anything else, write in the comment section. See you in the next video. Bye, good luck, and all time have fun.